I am right now very scared.
Okay. Oh, it should be live. Yeah. Okay, I'm gonna ping the Livesolve people. Okay. Okay. Yeah, we should be able to start. So, hi guys. I'm Ashman and I'm with Pro Electro, and today we're going to be live solving the 2021 IPHO no IPhO problems. So yeah, today we're going to be doing uh, theoretical 1 and theoretical 2 for today. So yeah, I guess we can start. And I'll pull up the first problem and we can just read it, I guess.
So we will show the question paper in the stream or
Yeah, I have it on the stream. Yeah, so they should be able to see the question paper right now.
nice.
Okay.
So we can read it aloud turn by turn. The problem.
Okay, sure. Consider a large vessel of water that is situated in a uniform gravitational field with all freefall acceleration g. Uh, Two vertical rectangular plates parallel to each other are fitted into the vessel so that the vertical edges of the plates are in a tight gap-less contact with the vertical walls of the vessel, and the length h of each plate is immersed in the water, and the width of the plates along the y-axis is w, and the water density is rho 0. Okay, and then oil of density rho oil is poured into the space between the vessels, between the plates, until the lower level of the oil has reached the lower edge of the plates. Assume the plates and vessel edges are high enough for oil to not overflow them, and surface tension and mixing of fluids can be neglected. Okay. Okay, so that's pretty straightforward. And it's asking, the first one is, what is the x component of the net force that's acting on the right plate? And they want the magnitude and direction.
Okay, so we can first balance the pressure of oil and water to find the H dash. I guess.
And to find the height of the oil?
Yes.
Yeah, that would work, yeah. And then we can find the force after that, because then we know the
Yes.
total area.
So let us take this H dash.
Okay. So,
What is the density of rho given?
just rho sub oil.
Oh,
I guess you can abbreviate it.
yes. Let us take a rho O or rho 0.
Okay. Then we have raw water. So I can just say we can Yeah, rho W.
Yes, rho W into hg.
Okay, then we find H prime.
Yes. So now we have to find only the force.
Okay, so since it's rectangular, yeah, so
Yes, we can midpoint pressure into area. We can do that, I
yeah,
assume.
okay, and then yeah, so
So we have to take this area or the complete area.
I think complete area because the entire oil is acting on the H prime.
Yes, yes, yes.
Okay, so then average pressure. So you do average pressure times area.
Yes, rho g h dash by 2.
Yeah, yeah, you can do it.
What is this width given?
Just W. Okay, and that's the force from the oil. And then so
Yes, and same we can do for water.
yeah,
I guess this should be the answer.
yeah, that should be answer for part A1.
Yes. We
Can
have to substitute this, but
yeah.
I guess the main idea should be this.
Can anyone who uh is watching the live solve confirm this answer? Okay. No, I think since it's okay, no one's saying if it's correct or not, but I think it's correct. So we can just continue with the next part.
Okay, yes. So I'm reading this question. Figure 2 shows a cross section of a mid-ocean ridge. It consists of overlaying layers of metal crust and ocean water. Figure 2. Oh, water, crust, mantle.
Okay.
The mantle is composed of rocks that we can assume can flow in the geological timescale, and therefore, in this problem, we will be treated as a fluid. The thickness of the crust is much smaller than the characteristic wavelength in the x direction. Hence, the crust behaves as a freely bendable plate. Okay.
That makes sense.
To To high accuracy, such a ridge can be modeled as a two-dimensional system without any variation of the variables along y-axis. What is y-axis? Okay, the plane
Yeah.
outside the plane, which is perpendicular to the plane of figure 2. Assume that the ridge length L along the y-axis is much larger than any of the length introduced in the problem. Okay. At the center of the ridge, the thickness of the crust is assumed to be 0. Yes. As the horizontal distance x from the center increases, the crust gets thicker and approaches a constant thickness t as x tends to infinity. But I have a doubt here. Why? How can we assume center? Okay, ocean water. We can assume ocean water limited, so there exists a center.
Yeah, I think the center here is just like the origin of the XYZ coordinate thing.
But everything is symmetrical for others also. So why should there exist a center? if there is an infinite ocean water.
I guess I yeah, that's true. But I guess the centers where the water, the crust, and the mantle all meet at one point. So like point
Or
O.
we can assume there is finite but very large than H and D. So then this can make sense.
Okay. Yeah, that can make sense too. Yeah.
Correspondingly, the ocean floor subsides by a vertical height h above the top of the ridge. Okay. Water density rho naught and temperature T naught can be assumed to be constant in space and time. The same can be assumed for mantle density rho 1 and its temperature T1. The temperature of the crust T is also constant in time but dependent on position.
Okay, so like at some point Z will be constant.
It is known that to high accuracy the crustal material expands linearly with temperature T. Since water and mantle temperature are assumed to be constant, it is convenient to use rescaled version of the thermal expansion coefficient. Oh, here T
Okay, we should.
L of T. I think I have to read the let,
We should write that formula down.
yes, and I am. You can use plus symbol to add this. Add another screen
Oh, no, plus.
here.
Oh, okay.
So if you want, we can go backwards, or if you erase, then we can't go back.
Oh, this is convenient. Yeah. Okay, I'll write this down. So L of T is equal to L1 times 1 Okay, that's kind of big, but it's fine. And then L is the length of a piece of the cross material, and L1 is the length at a temperature T1, and K of L is rescaled thermal expansion coefficient. Okay, so L1 is the length of the mantle crust piece, or the mantle boundary. Is that what it's saying?
I have completely lost the track, so let me read it again silently.
Okay.
Okay, so I got it. L1 is the length of the crust.
Wait, what?
I got it. L1 is the length of the crust.
Okay, sure, yeah. And then A2, assuming the crust is isotropic. Okay. and then find how the density rho depends on its temperature T, assuming that KL is much less than 1, and write your answer in the approximate form of, so yeah, that, where terms of order KL squared and higher are neglected, and identify constant K. Okay, that looks pretty similar to the formula for the length of the crust material.
Yes. And as it is isotropic, I think we can directly multiply by 3. For volume expansion.
Okay, well, density is mass over volume, so I guess we can just rewrite this in terms of volume. So L
Yes.
is,
So mass upon volume. That is dimensionally L1 cube.
yeah.
Is this K or eta? I guess it is K. So I guess we can directly do binomial approximation and we can do 3L, 3K here and the same term here.
Yeah, and then M over L1 cubed is just,
Row 1.
yeah. Okay, that was straightforward.
Yes.
Okay, let's do A3 then.
By assuming that mental, okay, wait. It is known that K is greater than 0 almost. Also, thermal conductivity of the crust K, sorry, kappa, can be assumed to be constant. Okay. As the consequences very far away from the ridge axis, the temperature of the crust depends linearly with the depth. Okay, temperature depends linearly. Okay. By assuming that mantle and the water each behaves like an incompressible fluid at hydrostatic equilibrium, express the far distance crust thickness d in terms of h, rho naught, rho 1 and k. Any motion of material can be neglected.
Okay, why did they tell us thermal conductivity is constant and the temperature of the crust depends linearly with depth? Oh,
I
it's,
guess temperature, yeah,
oh, that's like you can use Fourier's law, right? Like Q is equal to kappa. Okay, so the heat flux density is constant, I
okay,
guess.
I guess it is like an incompressible fluid. So that can make any sense. And equilibrium. So we can write the equation of equilibrium for this and far apart.
Oh yeah, yeah. Because at boundaries the pressure would be the same.
Yes. So so for pressure, I guess we have to do rho g h, and for rho we have to use temperature, and that we can find by linearity.
Okay.
Also, in the earlier part, it is given that T naught and T1 are constant, so we can use that also.
Yeah, because yeah, so T1 and T0 for water and mantle. Okay.
Okay, there is no crust for origin, so we can directly find the pressure of mantle at H plus D by directly rho G H plus D.
Yeah, okay. So,
P at 0 is equals to rho. Oops. Rho, rho G H plus T. Here rho is rho of water. What is it given? Rho naught. But at pressure at infinity there is a crust layer, so I guess it will be tricky.
Oh,
We can do rho crust. Oops. Crust G H. But H we as crust is varying, we have to DH and then integrate.
yeah, so from H to H plus D.
Yes. And before H there is rho not GH also. That can directly cancel this. We,
Yeah,
so temperature, we can use kappa for that.
okay. Oh, yeah, then we can
So this
direct.
equation I guess will helpful then.
Yeah, so then just Fourier's law. So T would be something like T1 minus T0 or Z minus H over D. Yeah, is that right?
So here I have to write Z not H, or this will confuse. That will get. What is the T? Oh yes, I think that's right. But we have to use kappa here, no?
Oh yeah.
Or kappa will get eliminated. Okay, we can use without kappa also, but there is kappa given.
Well, it says it's constant, so I think it gets eliminated, unless I'm wrong.
But I think there is an excess data. We can find kappa with T1 and vice versa. So we have to submit in which. Okay, they have told that we have to term in H, rho not rho 1 and K. So I guess kappa we have to ignore.
Oh yeah, it says in terms of yeah. Okay, then we don't need kappa.
So
Okay, then
we
it
have
just
T. So we can use the equation earlier found rho crust equals to what we have found 1 rho 1 1 plus K.
3K.
Yes, 3K. 3K T1 minus T naught by T1 minus T naught. Okay, here.
Oh no, this is T. Yeah.
Yes.
So then you just plug in T
So
for that.
won't it become very ugly?
Yeah, that's what I was thinking. Oh, well, if it's just a fraction, it shouldn't be that bad.
Okay, let's try. So rho naught GD equals to, is this D only? Yes, it is D. But it's capital D. Rho 1 is constant, G constant. Mm, 1 plus 3k t1 minus. I guess we should write t here only and convert dz into dt. So it would be meter. So dt would be equals to t1 minus t naught dz by d.
Yeah.
So we can write d dt by t1 minus t naught. So we can cancel this d and this d. I guess we have to erase the upper part or make a new screen to write this. But erasing upper part will be beneficial, so we can directly see or we
Okay.
rho naught g equals to, we can cancel this g. I am not able to erase.
Yeah, this is messy.
Yes. Rho 1 and integral of from t0 to t1 1 plus 3k by t1 minus t0 t1 minus t dt, and we can put t1 minus t0 here. So erasing this,
Okay, and then t1 minus t0 is just constant. So this is just an
yes,
easy
this is
integral.
linear integral direct.
Yeah.
So can you continue this?
Okay, so how do I get? Wait, what? Okay, wait. I don't have my marker for some reason.
Let me continue. Rho naught t1 minus t naught equals to 1, that is t1 minus t0 plus 3k by t minus t0 t1 into t1 minus t0 minus t1 square plus t0 square by 2. So this will be cancelled out. So we have rho naught equals to rho 1 plus 3k by t1 minus t0 multiplied by t1 minus t1 plus t0 by 2.
Okay, and we need to find d.
Or we can write this simplified as t1 minus t0 by 2. So sorry, what we have to find?
We have to find d.
We have to find d. In my case, d eliminates.
Yeah, which is a problem. Oh,
What have I done wrong? Okay. This density part is right. This is, I guess, right. Hmm. So from here we are getting rho 1 in terms of rho naught, right?
Yeah. Let me look back at the figure. Maybe the okay, wait, how do you get rho 0 GD?
That I got here. Why is this control Z not working? Yes, it is working now. Oh, that part I guess you have erased, so I can't do control Z. But I got it from row rho 0 G H plus D equals to rho O, I guess. No, rho 0 H plus rho crushed G D Z integral.
I think it should be rho 1 G H plus D.
Why? Let me take a rough diagram. Here is this is water. So here it is right there. Looks like this. So at infinity we have this H with rho water only, and here is rho crushed, and
Yeah.
here is metal. So here rho naught Hg only will happen.
Yeah, so rho naught GH plus the pressure due to the crust, which should equal
Yes,
to the pressure exerted from the mantle, right?
yes,
So
yes,
then
yes, yes.
we should use rho 1 instead for GH plus D, as the mantle goes for an entire height of H plus D.
Oh, that's why here would be rho one. Now it won't cancel, and D would be given as answer. Here T1 minus, where is T? Here is, I guess, T. Yes. And can you write the expression you found for temperature as a function of Z?
Okay, so it's like T of Z is what is it? Oh yeah, T1 minus T0 Z minus H over D. Oh wait, so since the initial temperature of the water is T0, then we should also add that as it added. Yeah, so this should actually be temperature Z and as a function of Z.
Okay. And you have this is as Z equals to H, and this is Z equals to H plus D, right?
Yeah.
So if we put H plus D, we get D by D. Okay, then we get T1. Yes, you are right. So we can now differentiate this. If we differentiate, then this T naught won't matter.
Yeah.
T1 0 dz by d. Yes. Now we can substitute dz here.
Yeah, then we'll get in terms of temperature.
Or we can continue this in the new screen. Let me write it somewhere.
Good where?
In my notebook so that we don't forget this, and then we can continue this in a new screen so that it we don't have to rub all the.
Oh yeah, that's a good idea.
Okay, you can make a new screen from here. So we have two equation, dt equals to t1 minus t0 by d into dz, and rho 1 g h plus d minus rho 0 g h equals to the integral.
Yeah.
And we have rho as rho 1 1 plus 3k t1 minus t by t1 minus t0, and we have dz as g. Okay, g can be cancelled in every term, so we have d by t1 minus t0
DT.
dt. So we have this integral rho 1 d by t1 minus t0 t1 minus t0 plus 3k by t1 minus t0 t1 into t1 minus t0 minus t1 minus t0 square by 2.
Yeah.
So we can eliminate this t1 minus t0 and have plus here.
Okay, that
And
expression will
also,
be messy.
no, it will get simplified if we cancel this t1 minus t0 plus 3k, as this also gets simplified to t1 minus t0 by 2 if I have not done any calculation mistake. Yes, and we can cancel this also.
Okay.
So we have rho 1 into h plus d minus rho 0 h equals to rho 1 d times 1 plus 3k by 2. Can you bring new screen so that we can continue? From previous expression, we have rho 1 h plus d minus rho 0 h equals to rho 1 d 1 plus 3k by 2.
Oh, okay.
So from here we have to find d. So we can bring it here, and rho 1 h minus rho naught h by rho 1 into 1 plus 3k by 2 minus rho 1 equals to d. I guess this should be the answer for the second part.
Yeah, I think that's correct. And let me ask chat. Okay, yeah, did you guys, if you guys have like, are you looking at the solutions, then is this answer correct? Okay, apparently it's wrong.
Hmm. So what can we have done wrong? I think we can have done a calculation mistake.
Yeah.
Can you go to previous slides to check it?
Okay,
I think we should check from the beginning.
one person's asking how he found dt. So we have this expression of t of z from boundary conditions, and we just differentiated with respect to z. Oh, okay. Someone is saying it's correct actually, and they made a mistake. Okay, then we can just go on to the next problem.
Okay.
Uh, so A4. Find the leading order in K, the net horizontal force F acting on the right half. So right half is x greater than 0. Or the crust in terms of rho 0, rho 1, H, L, K, and G. Okay, this seems a bit more bashy now.
I think this is like a first problem only.
Yeah, I think it's similar to that problem too. But now you have to integrate.
No, rho is constant for x equals to 0 as it is mental.
Wait.
So we have to find force in 0 minus force at infinity. So I guess force at 0 is directly like first problem, but force in infinity will be complicated.
Yeah. Well, I guess you can use the pressure we found from the last problem.
Yes,
For like z in between h and h plus d.
but we have not, I guess we have not simplified it and directly eliminated the terms that doesn't require.
Yeah.
Okay, for part x0, we can directly do rho 1 times g times h plus d by 2 into h plus d by d into L. This is f at 0. F at infinity will be complicated. For that, I guess it will be rho 0 into g h by 2 uh, L plus integral.
Yeah, so like,
Can you go to previous slides so we can have a look at the pressure?
yeah, this should be.
Yes. Okay, but we have not find at general height h.
Or
But here also we can convert into dt, I guess.
could we? Oh yeah, I guess actually.
Or we can use double integration.
No, like it maybe L times. Uh,
I guess this is pressure. So for force, we have to integrate once more.
oh yeah. So then, what did that integral be?
Into cross-sectional area. So one more time dz. Or let's say this is equals to P. And then we have P into L dz from H to H plus T. And this L we have to eliminate because for P it won't come. So we have to find this independently first and then. So for first part, if we have done more calculation, then here we won't have to. Okay, can you make another slide so can we can find P first and then substitute here directly?
Oh, okay. So integral was. Yeah, I can just plug in the general formula of T2. Yeah, this is. Oh, bro. Okay, so you have to find P. So yeah, I guess you can just use the dt dz substitution again.
But for force, we have to find general Z. So I guess dt substitution won't work here.
Okay,
Or
well,
we have to substitute dt there also.
okay.
But I think Z will also work fine here as everything else is constant.
Yeah, it'll just cancel out. So this won't be bad. Oh,
Yes.
And this would, yeah, am I? So these two would cancel out, right? Like this,
Yes.
and then we just have hz rho 1 plus h 1 minus z minus h over d g dz, and then these will be constant, so we have rho 1 g z minus h plus rho 1 times. Wait, okay. Wait, this is messy. Oh. And let me try to simplify this. One sec.
Yes, we can common out z minus h.
Yeah.
And also rho 1.
Okay. So yeah, that's just the formula for pressure. And then you have to again integrate. Let me write this down.
I think you forgot one g,
Oh, where?
because there is the dimensional error here, because here is the g but here it is not.
Oh yeah. It doesn't.
You can write g outside only and then here 1.
G should be in all of these actually. So they should be 1.
Yeah. Yes, and g should be outside. So we have rho 1 g into z minus h into 1 plus h 1 minus 1 half z plus h minus h by d.
Yeah.
So I have rotated. Can you go to previous slide? Previous one, because we have left f expression there. And can you erase this expression and write that PLDZ?
Yeah, which expression? No, you can do it.
I can't erase your drawings, so
Oh, okay. Oh, this one.
yes. So we have integration from h to h plus d L times P times dz, or we can directly substitute P here, that is rho g, rho 1 here, rho 1 g z minus h times. Yes, this is really becoming messy because we have to do integration now. So f infinity will become h square L by 2 plus rho 1 G L H plus D. For integration, do we have to multiply or we can do by parts?
I think you can just do it by parts.
Okay, but I think we should differentiate this and integrate this. Or we can, I think, directly multiply so it won't become that complicated.
Okay, sure.
Z minus H plus H into Z minus H by 2 Z square minus H square minus H Z minus H by D dz. Okay, this has become a huge expression now. Now I think we will surely do some calculation mistake here.
Honestly, we can just leave it like this.
Yes,
Yeah, because like
we
there's not much else to do.
yes,
Okay, why don't you just go into A4 then?
and we have also lack of space. So
Yeah.
okay, for A5. Suppose that crust is thermally isolated from the rest of the earth. As a result of heat conduction, the temperature of the upper and lower surface of the crust are going to get closer to each other until the crust reaches thermal equilibrium. Specific heat of crust is C and can be assumed constant. By using dimensional analysis or order magnitude analysis, estimate the characteristic time in which difference between the upper and the lower surface temperature of the crust far from the rigid axis is going to approach zero. You can assume tau does not depend on the two initial surface temperature of the crust.
Okay,
I
so
completely didn't get the question.
they just want us to find the relevant parameters and then use dimensional analysis.
But I don't understand what is the characteristic time tau, how it is
Characteristic.
defined as.
Yeah, I don't know what that is either. It's like,
Is there some wave going from upper to lower surface?
yeah, that's what I was thinking, but it doesn't say anything about that.
Yeah.
Maybe characteristic time for heat to
But they have
increase by.
told to ignore the two initial temperature. I guess that is water and crust temperature. So we have to only find temperature in matlab, temperature or rho one in terms of rho one.
Okay.
So from this, I don't get what is tau, but it is dependent on rho one or sorry T1
I guess you
temperature
can
T1.
say also dependent on specific heat, since it says it here.
Yes. So C.
Also, since heat conduction it says heat conduction too, so maybe thermal conductivity. I don't know.
Yes, kappa.
What else? Oh, we need a length parameter too, since
But which length parameter, D or H? If we include both, then the dimensional analysis won't help us.
well, if it's the cross, then it should just be D.
And also we have L as a y-axis parameter. So which one we should take? But I guess it is different in upper and lower surface temperature. Then I should I think we should take D as a parameter because
Yeah.
D is the difference between this.
Okay. I kind of forgot the dimensions of C and kappa. Do you remember them?
C is MC delta T. So this is heat. So this is joule. So kg Kelvin. So C should be joule per kg Kelvin. Or if it is heat capacity, then joule per Kelvin.
Okay.
Is it specific or yeah? It is specific heat. So I guess this should work. And dimension of this kappa is K A delta T by L equals to power. So power is joule per second. So we have a area. So we have meter here and Kelvin here. So kappa should be joule per second meter Kelvin. This is kappa and this is C. And D is here meter and T1 is Kelvin. And J is kg meter square per second square. So we can plug in. So K would be kappa would become kg meter square per second square by second meter Kelvin. So kappa is this,
Okay.
and C is kg meter square per second square Kelvin, and D is meter and T1 is Kelvin. Yeah, I guess I can erase this all. And we have to find the characteristic time, that is second.
Yeah.
So tau equals to second.
So then, alright, we have temperature. Actually, I don't know temperature, but I can just say like Kelvin. And then L. So then we have like 4 equations. Yeah, 4 equations. Okay, wait, so for mass, the only one that's dependent on mass is heat conductivity. So A is 0. Wait, no, it doesn't make sense. Oh, wait. Wait, is M here like meters or is it?
It is meters only. I think I have messed up in dimensional analysis of C.
Yeah.
Let me do it again. So C was, is it specific heat capacity or heat capacity? I don't remember.
Let me look.
It is specific it only.
Okay, yeah, then
So,
there should be some mass
so,
component.
so mass term should be cancelled out as here we have mass into specific it into temperature, and here we have joule, that is mass. uh, matlab, joule has also a mass term, so we mass term would be cancelled out, so only this is mass term. Or I guess we have done dimensional analysis wrong. Matlab, we have taken these four parameters wrong.
Okay.
Can anyone in the chat confirm that is a zero or not?
Yeah, that would be good.
No one is confirming.
Oh wait, did we introduce density?
Oh yes, we forgot about the density.
Yeah.
Yes, density rho 1 will also play. But here rho 1 and rho naught both exist. So should we take rho 1 or this characteristic time is so complicated.
I guess you can just say it's like one of them.
Then we have five parameters and only four equation of mass, length, time and Kelvin.
Yeah, that's true. Well, I guess we can throw a temperature because the other parameters will take into account of that. I don't know.
Oh yes, we can do that. So
Yeah.
temperature gets eliminated. Don't rub all S, that would be required. Here only one change has occurred. Rho 1 equals to kg per meter cube. So rho 1 and kappa should be inverse of each other, so to cancel out kg.
Yeah.
So if we multiply, then dimension would be left, which is m4 by s cube k. And to cancel out k, we have rho 1 of dimension k s square by m square. So we can eliminate k and have s below. And to eliminate, we have dimension of d square. So we can do whole inverse to guess s. So by dimensional analysis, if we take these parameters correct, then we should get tau as this. But we don't know this constant, arbitrary constant that will occur after dimensional analysis.
I guess that's fine since it says to just use dimensional
Yes,
analysis.
they have also told that we have to do with dimension only.
Yeah.
There are only 10 viewers left.
Yeah, that's fine. That's more than when I live saw it last time,
Oh.
which is cool.
So we can do next question if this is correct.
Oh yeah, can the viewers confirm? So like if you have, okay, to like, so this is our answer for A5. So if you guys are looking at the solutions, then it would be helpful if you confirm the answer.
Okay, so someone said it is correct. So we can proceed.
Okay. Then we're on to B1. Okay. Suppose
Suppose
that
that,
suppose
okay,
that
you read.
oh you can read it.
No, I guess it is your turn. I have read
Oh,
previous
okay,
one.
sure. Suppose that a short earthquake happens at the surface of some planet. The seismic waves can be assumed to originate from a line source that is situated as z equals x equals 0. So like the line source is in the page in the diagram. Okay. And where x is the horizontal coordinate and z is the depth below the surface. The seismic wave source can be assumed to be much longer than any other length considered in this question. As a result of the earthquake, a uniform flux of the so-called longitudinal P waves is emitted along all directions in the xz plane that have a positive component along the z-axis. Since the wave theory in the solid is generally complicated, in this problem we neglect all other waves emitted by the earthquake. The crust of the planet is stratified so that the P wave speed v depends on the depth z according to v is equal to v0 1 plus z over z0, where v0 is the speed at the surface and z0 is known as a positive constant. So consider a single ray emitted by the earthquake that makes initial angle theta 0 is less than theta 0 less than pi over 2 with the z-axis and travels in the xz plane. What is the horizontal coordinate x1 of theta 0 not equal to 0 at which this ray can be detected at the surface of the planet? It is known that the ray path is an arc of a circle. Write your answer in the form x1 of theta naught is equal to a cotangent b theta naught, where a and b are constants to be found. What does it mean by ray? Like, is the ray like a wave?
Yes, I guess it is. But if it is a ray, then we can apply Snell's law. And also they have said it is arc like. So
Yeah, I think it's like an optics problem in disguise.
yes. I have made one such similar POTD also.
Oh yeah, I remember that.
Is theta not angle from the, yes, it is horizontal angle. So we can write any general at any general equation theta cos theta by v equals to constant equals to cos theta naught by what is the initial velocity? It is v naught. So we can directly integrate from this, I guess. And v is cos theta by V naught 1 plus Z by Z.
Yeah.
So let us convert this cos theta into tan theta. So we can replace it dy by dz instead of that. So 1 plus z by z naught, and we can square this, and then inverse this. Therefore sec square theta equals to 1 plus z by z naught
Are you sure
1.
it's supposed to be cosine theta?
What?
Are you sure it's supposed to be cosine theta, not sine theta?
Because in Snell's law we have normal angle with normal, so we have taken angle with horizontal, so that is 90 minus,
Oh, okay.
and subtracting 1 we can get tan square theta, that tan theta equals to under root of 1 minus uh, 1 plus square cos square theta by, but this is getting very messy as this is dz by dx. This is theta naught.
Okay. Uh, Maybe there's a simpler way to do it.
Yes, I should erase this. Or we can do reverse substitution instead of this. We know tan theta equals to dz by dx. So we can, okay, we can differentiate this to get cos theta sin theta minus d theta equals to, and we can substitute this as 1 plus z by z naught. We can differentiate this dz by z naught cos theta naught, and then plug here value of dz. So we can get tan theta dx equals to dz. And what is dz? It is minus sine theta d theta z naught by cos theta naught. So this can cancel out by cos theta, and we can have x equals integration of cos theta, that is sine theta, z naught by cos theta naught plus c. What we have to find?
Um, the horizontal coordinates at which the ray can be detected on the surface.
But it is in terms of cot theta, and I am getting sine theta. Okay, we can plug in theta, so we can get cos theta. So we have to first plug 0 Okay, we can get C as equals to 0 by plugging x and theta both as 0. And if we plug x equals to x naught, then we can get minus tan theta naught uh, times z naught. So I think this is similar to this,
Yeah.
but it is cot theta instead of tan theta. I think I have messed up in theta. Okay, let me do it again. Or I guess you can do it
Oh wait,
this
no.
time.
It's supposed to be sine theta, like uh, when you're using Snell's law, because it says with respect to the z-axis. So that's with respect to the normal.
Wait, where is theta naught is angle with horizontal or vertical?
With vertical.
Oh, that's why. So we have this theta naught. Okay, then we have sine theta only.
Yeah.
Yes, you are right. Then we can put general theta. But then dz by dx won't be, it would be cot theta. And we have b, okay, sine theta naught by v naught equals to sine theta by v. V is v naught 1 plus z by z naught.
Yeah, and then you can just differentiate.
Yes, we can just differentiate. So we have dz by z naught equals to into sine theta naught equals to cos theta d theta.
Yeah.
And when we can plug in dx cos theta here. So dx cos theta, cot theta. So this can be cancelled out by sine theta. And after integration, we have x sine theta naught by z naught plus c equals to minus cos theta. So if we plug in x0, then we can get c. C is not 0 here because this is 1 and therefore C would be 1 minus this. But this is not how I expected it to be. So if you plug in, I am getting x by z naught equals to 1 by sine theta naught minus cot theta naught.
Okay, the wait, let me check. Let me try something. One sec. Okay. And so how do you get this expression?
This, okay, let me do this again. So we have this expression and I differentiated this after taking this here. So I got sine theta naught by z naught equal into dz equals to cos theta d theta. Is this right?
Yeah, I got that.
Then then I plug in the value of dz. So that is dx cot theta. So we have sine theta naught by z naught into dx cot theta
And so
equals
dx is
to,
horizontal coordinate.
yes, dx is horizontal coordinate. Therefore, we can write uh, this as sine theta naught by z naught times dx equals to sine theta d theta. And then we can integrate it from uh, x equals to 0 where theta equals to theta naught. Oh, I guess I messed up here. And then uh, here it will be, okay, we don't know the, wait, I completely messed up. We have z coordinate 0. So we have, I am not getting what we should put as a limit here. For 0, I have theta naught for, but for this, I don't have any limit.
Yeah, I'm
Or
not.
should I put minus theta naught? But they, as they have given circular arc, we can assume. But if they have not, then how can we prove that this will be minus theta naught only?
I guess you can prove that it's a circle. So like, so look at the path length, I guess. Oh,
Okay, we can plug here z equals to 0. So we have sine theta naught equals to sine theta. So we have two solution. One, pi minus theta naught. So here is pi minus theta naught, not theta naught, I guess. Pi minus theta naught comma theta naught. So sine theta is cos theta, negative cos theta. So cos theta naught minus cos pi minus theta naught. So we have cos pi minus theta naught. That is minus or plus. I guess it is minus. So we have 2 times this equals to sine theta naught x naught by z naught. Okay, we can get 2z naught equals into cot theta naught equals to x naught. If I have done this correct. Can you check this step
yeah,
from
yeah.
x naught?
Okay, I got the same answer. I got the same answer by doing that.
Yes, so we can proceed to next question, or we can ask them.
Yeah, we can ask the chat. Also, if you're watching and had the solution with you, do we get the right answer?
Also, I think there is a delay in the stream.
Yeah, I think there's like 20 or 30-second delay. I don't know.
Yeah, so they take some time to answer.
Okay. Well, yeah, one of them said is correct. So we can continue.
Yes.
Okay,
So
B2.
if you were if you are unable to find A and B in the following question, you can use the result x1 theta naught equals to A cot B theta naught as a given. Suppose the total energy per unit length of the source released as P into the crust during the earthquake E. Assume that waves are completely absorbed when they reach to the surface of the planet from the below. Find how much per unit area, energy density per unit area. I guess it should be energy per unit area only. Uh, Epsilon x absorbed by surface depends on the distance along the surface x. Sketch the plot of E of x.
Okay.
So they have not given the function of energy that is emitted as a respect of theta. So I guess we can treat them equally radiated in all direction.
Yeah. So like we can consider
D
like
theta element.
yeah, you can consider like this area.
Yes. So we can get that energy from x to dx.
Okay. So
So energy would be E into by pi into d theta, as they can, or they can emit upper also, but I guess as they have said absorbed here, so they can occur in pi only. Yes, by dx equals to energy here epsilon. So we have to just find d theta by dx.
yeah, and we can use that with our formula.
Yes, x equals to 2 cot theta naught into z naught by z naught. So we can differentiate this. So dx equals to z naught 2 cot theta cosec square theta
Yeah. D
d
theta.
theta naught. So we get sine square theta naught by z naught 2 into e by pi.
Yeah.
But I don't think this is 1.5 points worth.
Yeah, me neither.
Okay, we have to find function of x. So we have to plug back the sine square theta in terms of this. But still, I don't still think it 1.5 points worth.
I guess because they want us to sketch it.
Yeah, but here we can continue to next questions instead of sketching, if this is correct.
Yeah, okay, we can ask in chat. So is this part correct? No one's saying anything yet.
Yes, but I don't think anything wrong in this, so we can continue for next part.
Yeah. I guess the only thing is that we had to express in terms of x, so maybe that confused some people. But yeah, let's go to B3. Okay, 2 points. From now on, assume that the waves are instead fully reflected when reaching the surface. Imagine a device positioned at z equals x equals 0 that has the same geometry as the previously considered earthquake source. The device is capable of emitting P waves in a freely chosen angular distribution. We make the device emit a signal with a narrow range of emission angles. Uh, okay. Uh, in particular, the initial angle the signal makes with the vertical belongs in the interval theta naught minus 1/2 delta theta naught theta naught plus 1/2 delta theta naught, where 0 is less than theta naught less than pi over 2, and delta theta naught is much less than 1, and delta theta naught is also much less than theta naught. And at what distance x max along the surface from the source is the farthest point that the signal does not reach? Write your answer in terms of theta naught, delta theta naught, and the other constants given. Okay.
So I guess here also we can use the property of light of reflection.
Yeah.
So this will look like something this. And this will look like this.
Hmm. Horizontal distance would increase with each reflection.
Yes, so for this it will the I think thickness will increase,
Yeah.
and that too proportional to the number of reflections. So if two reflection we can multiply by 2 times the thickness because it is linearly dependent.
What is x here?
Okay, we can say it as t. So 2t will be the thickness of this.
Yeah.
I think I have made a messier diagram. I should choose different colors. For this, I can do this one. this will be red and this will be green. So this is T, this is 2T, this is 3T. So this part is not reachable, this part. So if we somehow make, and this part is becoming smaller and smaller. So if we make this part 0 for next reflection, then we can find n, I guess. Am I correct?
Yeah, I think that's right.
But how can we find general expression of this in terms of t? Or
But
we can direct.
initially T would be this, right? From like the first part. So
This
then,
is x naught, then dx would be the t here, because this is difference between them.
okay,
So it will be 2z naught cosec square theta naught
okay, and then
cosec d theta naught.
the angle the signal makes with the vertical is like, so we should express in terms of delta theta 0 2.
This is delta theta naught only. As this is small, we can use the differentiation. So t equals to 2 z naught cosec square theta naught into delta theta.
Okay,
But how from t, how will we find this? Or we can approximate this to be this, but for large n. This is
for
basically distance. Let's say this is nth loop. So this is upper end of this x of theta plus theta naught plus delta by 2 of nth turn minus x of del theta naught minus delta by 2 of n minus 1th turn. This value is this. So this should be same, equal for,
approximately.
yes, approximately equal.
Okay,
So we have to find this and multiply it by n equals to n minus 1 times what we can write is 2z naught cosec cot theta plus delta theta by 2 and 2z naught cot theta minus delta theta by 2. So we can eliminate this and solve this. So we have n into tangent of theta minus d theta by 2 equals to n minus 1 into tangent of theta plus d theta by 2. Can you uh, make next slide? So yes. So n into tangent of theta minus d theta by 2. Here d theta is that, but I am lazy to write that.
Yeah, okay.
So we can expand this tan theta minus d theta by 2 by 1 plus d theta by 2 tan theta,
That's
which is
the
equal.
okay.
And I have also approximated this tan to d theta by 2 by minus d theta by 2 tan theta, and we have to cross multiply this. So n times tan theta minus d theta by 2 minus d theta by 2 tan square theta plus I can neglect higher order of this, which is equals to n minus 1 times tan theta plus d theta by 2 plus tan square theta by 2 d theta.
Okay, what do you do now?
Expand RHS, but I have to first copy this. Can you go to previous slide? I have not copied it completely. Yes, I have now copied. So we have n tan theta minus n d theta by 2 minus n d theta by 2 tan square theta equals to n tan theta plus n d theta by 2 plus n tan square theta by 2 d theta minus tan theta minus d theta by 2 minus tan square theta by 2 d theta. So we can eliminate this. We can eliminate 2. We can eliminate 2. We can eliminate this also and this also. This will tend to 0 as they have as they don't have n, and as n is large and they have d theta which is small. Rest have either of them. So uh, this would become this would cancel out. So this will be sec square theta and d theta equals to tan theta. So n would be tan theta into cos square theta by d theta, which
Okay.
is sin theta cos theta by d theta.
Then to find the maximum.
So maximum would be n times 2 cot theta naught into z naught,
Oh yeah, because okay, yeah.
as they are completely circular. So we can write final expression as uh, cos theta by sin theta cos square theta 2 times z naught by d theta equals to x max.
Okay, that looks pretty concise. Yeah, we can
This is
ask the
z.
chat. Yes, is this correct?
Also, this question feels like 2 points. The previous one was not, didn't feel like 1.5.
Okay, said B2 and B3 are correct. Yeah, this one, yeah, it feels like 2 points.
Yeah. Also, we have just 7 watching, but 74 likes.
Oh, 74 likes? That's like the most likes you've ever gotten on this channel.
Oh. So,
Okay.
should we continue next theory, next set?
Yeah, we're gonna do next theory problem too.
Okay. Electrostatic lens, 10 points. Consider a uniformly charged metallic ring of radius r and total charge q. The ring is hollow toroid of thickness 2a less than r. This thickness can be neglected in the parts A, B, C, and E. Okay. The xy plane coincides with the plane of the ring, while the z-axis is perpendicular to it. As shown in the figure 1, in parts A and B, you might need to use the formula Taylor expansion. Okay. Calculate the electrostatic potential phi z along the axis of the ring at the z equals to distance from the center. This is standard result, I guess.
Yeah. So first one is just
Yes, k q by under root of z square plus r square.
yeah, and then second one we just Taylor expand. So
Yes.
KQ over oh
You miss the r. below.
The R? Oh yeah. Oh yeah. Okay, so then
But I think in exam we have to derive the first one also.
okay, so you can just
Yes, take some d theta and dq and then integrate. As the distance is constant, the q will become whole q. dq will become whole q.
and then charge is q over 2 pi r, and distance is square root r squared plus z squared. So lambda r d theta times q over root r squared plus z squared, and then we integrate this from theta is equal to 0 to pi over 2 and 2 pi. Right, so then that's, alright, we forgot k. Yeah, so when we do this, it should cancel out, and then we just get that. Okay, so yeah, I think that's basically all we need to derive, right? And we can do A3. An electron of mass m and charge minus e is placed at a point A where z is much less than r. What is the force acting on the electron? Looking at the expression of force, determine the sign of q, so the resulting motion would correspond to oscillations. The moving electron does not influence the charge distribution on the ring. And so like if you calculate potential, then
Yes,
v,
we can either differentiate or I have also memorized the answer because this is also standard result of electric field.
yeah. Okay, then, okay, so z is here, or okay, then that looks right. Just from, so then find the angular frequency of harmonic oscillations.
Okay, so I guess they want us to differentiate that binomial expanded one, or we can do that here also, but that would be easier if you differentiate that binomial one.
Oh, okay, so dv,
Also, we have to take, I guess, one more term, so we have a factor of z. From here, okay, from here also we can directly eliminate this z and I so this is force is z for small z. So we can write 2 pi under root m by k, where k is this.
yeah. Okay, then that should be good for particle.
Yes. So m by
Oh, oops.
okay. m by 4 pi epsilon naught r cube q z, not z, qe. This should be answer.
Yeah, I guess you can ask in chat. Yeah, so were all our answers for A correct?
But we have to find angular frequency. So I have done this 1 by omega. Omega equals to under root of q e 4 pi epsilon naught m r cube. This is the answer of angular frequency.
Okay, there are only 3 people in the chat right now, so I guess you can just continue.
Yes.
In part B, you can read it if you want.
In this part of the problem, you will have to analyze the potential phi r in the plane of the ring. Okay. For r less than r to the lowest non-zero power of small r, the electrostatic potential is given by q into alpha plus beta r square. Find the expression of beta. You need to use Taylor expansion formula given above. Okay. So for this part, we have plane where this is r, or I draw it a little bit bigger. This is r. This is capital R, and we take theta as a eliminate. Or I think I have to draw more bigger circle.
But do you have to integrate?
Yes, I think so.
I think you
Oops.
could use Gauss's law. That might be easier.
How?
Like you can make a small cylinder on the plane of the ring, and it'll be like of length 2z, and then you can use the
Can you
formula.
draw that? I am not getting what you are
See, like you have, and then so yeah, like this goes down on the plane. And then this is like radius r and 2z. So then, and since we have the formula for potential, we can just integrate all the sides of the cylinder, and then we can find the potential from that, I think.
So I still didn't get it, but what I get is this is the ring we want. We convert it into a cylinder. And how are we? What is the Gaussian surface here?
Wait, what?
For the ring, we have to put a Gaussian surface. So where is the Gaussian surface? This is
Questions?
the Gaussian surface.
Yeah.
Okay. So we have this, but won't it find electric field instead of magnetic, instead of potential?
Oh. Oh yeah. Wait. Well, that's fine, I think, because from the last part, we found so like the general potential is gonna be like and then plus the beta r squared term. Yeah, so
But this was above the plane. For this, we have to find in the plane.
true. Wait, let me think. Actually, maybe we should just integrate. I'm not sure
Yeah.
actually, but that would be kind of messy.
Yeah, but for me, integration is easier than to think all this
Okay, we can
because
try
R
that.
is we can use that. So we have k dq by r square plus small r square under root of minus 2r cos theta, and integrate dq is lambda r d theta, and we have to integrate from 0 to 2 pi. So we can use binomial approximation as r is very small, and we can neglect r square order term. So we have k lambda d theta by 1 minus 2 r by capital R cos theta minus 1 half power, which is equals to, I think we should erase this. And we have k lambda d theta one plus r by r cos theta, and the next term would be plus 2r cos theta by capital R square 1 by 2 into 3 by 2 by 2 factorial. Is this term right? I am not sure about it.
Um, I think it should be.
Okay. Then we have k lambda. For first term we have direct 2 pi integral. For second term we have 0, and for third term we have 3 by 8 into 4 r square by capital R square cos square theta integral from 0 to 2 pi, and 0 to 2 pi integral cos square theta, and 2 cos theta can be written as cos 2 theta can be written as 2 cos square theta minus 1. So this would be plus 1 by 2. So we have integral of 0 to 2 pi 1 plus cos 2 theta by 2. This would be 0. So we have pi here.
Yeah.
So total flux as a function of r equals to k lambda 2 pi plus 3 by 2 r square pi by capital R square. And this is alpha, this is beta. And what we have to find? We have to just find beta. Wait, I forgot to multiply k lambda here. So this is beta.
Okay.
And lambda will be q by 2 pi r.
So that's
Pi cancel out. So that will be 4. And
so 3.
r will become cube. This is capital R I by mistake. So we have 3 over 4 r square by capital R cube k times q as a beta.
So 3 over 16 pi epsilon naught r cubed.
Yes.
Okay. We can try next part then.
Yeah. You can read it if you want.
An electron is placed at point B, where r is much less than big R. What is the force acting on the electron? Looking at the expression of the force, determine the sign of Q, so the resulting motion would correspond to harmonic oscillations. The moving electron does not influence the charge distribution of the ring. So I guess...
So for here, Gauss law would work fine. But as we have found electric field as function of R, we can differentiate directly.
Yeah.
But if they have asked the B part directly, then Gauss law would work better. I guess they just want to find time period, but instead they use different method, which was lengthier.
So the force would be 8k over 4 r cubed. Wait.
By 8. Okay, you converted it into epsilon naught. No.
Right.
What?
Oh, 6.
You differentiated this quantity, right?
Yeah.
Then it would become 6 over 4.
So then
As we
3 halves. Okay. And then r.
1, 2 will cancel out, as R differentiation also will result in 2.
Wait, what?
Because we have term something beta R square, so differentiate will give 2 beta R. Yes.
Okay, so then that's the force. And then for force to be restoring, then Q must be less than 0.
No, greater than 0, as E is also negative.
Yeah, but here it's negative dV over dr, and then E is negative, so then it becomes
But
positive.
if we see just physically, if there is positive, then it would attract negative.
Wait,
But
what?
if it,
Yeah.
wait a minute. Is this part dominant or this? Okay, this can be less than 0, yes. Right, right. It should be less than 0.
Okay. Then you can do part C.
Okay. One wants to build a device to focus electrons an electrostatic lens. Let us consider the following construction. The ring is situated perpendicularly to the z-axis as shown in the figure 2. We have source that produces on demand packets of non-relativistic electrons. Kinetic energy of these electrons is E equals to mv square by 2. E is the velocity and they leave the source at precisely control moment. The system is programmed so that the ring is charge neutral most of the time, but charge becomes q when the electrons are closer than distance d over 2. From the plane of the ring shaded in the figure 2 called active region. In the part C, assume that the charging and discharging process are instantaneous and the electric field fills the space instantaneously as well. One can neglect magnetic field and assume that the velocity of electrons in the Z is constant. Moving electrons do not disturb the particle, do not perturb the charge distribution of the ring.
Okay.
Determine the focal length of this lens. Assume that f is greater than d. Express your answer in terms of beta from the question B1 and other known quantities. Assume that before reaching the active region, the electron packet is parallel to the z-axis and small r is less than capital R. The sign of Q is such that lens is focusing. Okay.
Okay, well,
So we have a ring like this, or we can say disk like this, and an electron particle is going. So they will experience force here at this region.
and the
So for
forces.
time, what is this? D by V, they will experience force. Let's say force is F of R.
So force is what you got from part B1, right?
Yes.
B2.
Then this will be dV by dt. So we can find the velocity y, sorry, z velocity. This axis is y, right?
Yeah.
So we can find y velocity at the time of emission and initial velocity vy 0 equals to 0.
And then for.
And then find the angle and then find the focal length.
Okay. Then.
Can you say what we got f of r?
So E. Wait, let me write this down. Oh yeah, it also says to express in terms of beta. So let's look at what beta was.
Okay, so we can directly look at the question. and that is okay. 2 beta r into q is the f.
So when it moves with the velocity v travels time it's inside is d over v.
But we have r and it is variable, so I we have to convert it first. Or can we assume r approximately constant?
I think we can assume it's constant. So like
But r is also less than capital R. So I'm
much less
not
than
sure about it. That we
no,
can
if it's much less than capital R, then we can just assume it's constant, right? Because it
no, it can change from here to here. Here r is big, but here r can be small. So force can vary from here to here.
uh yeah, true.
So we will get some exponent function. No, this is minus no. Why I'm taking so we can get some sine function after we have d square r by dt square as this is minus r, so we can get a sine omega t. Or
Wait.
now as this is becoming very complicated, I assume that this must be constant approximately.
Yeah, I think it should be constant because it shouldn't vary that much when it's inside the ring. It only it only changes a lot when it goes outside.
Okay, can you continue this question? I have to go to washroom and then.
Yeah, sure. Okay, so then change in velocity is from what's written here. dv dt is equal to f over m. So change in velocity is just this, and we also know that t is equal to d over v. So then in the end we get something like 2 beta req over m d over v. So that's the velocity that's gained by the electron when it goes through the electrostatic lens. So then what's it asking for? It's asking for the focal length. So to find the focal length, we just need to find the total time it requires for the electron to get there. So as r is much less than r, so that implies that r squared plus little r squared is approximately r. Oh, actually, d. Like, I'm just gonna assume that r is much less than the focal length. Let me erase this. So the electron is going to travel in a time t, Okay, wait. Okay, wait, never mind. That's, we can't assume that because that's not in the question. And so the time for the electron to reach the axis of the thing is just going to be the vertical distance divided by its gain and velocity. So it's just going to be mv, so t is equal to mv over 2 beta 2 beta r eqd. Actually, no, there's no more r anymore.
Okay, I am back.
Okay, I was just finishing this.
What is this capital T?
It's the time for the electron to reach the optical axis.
Okay.
So just r over delta v.
Yes.
Yeah, and then if the electron is moving with the velocity v, then the time for it to then the focal length is going to be,
V times capital T.
yeah. But then we don't know what the velocity of the electron is.
Isn't it given?
Oh yeah, the kinetic energy. So we can plug
Yes.
that in.
So mv square by 2 can be directly written as V. E.
So beta EQD.
So this is our answer.
Yeah.
Should we ask chat?
Yeah. Uh, if anyone's watching and has a solution, then is what we got correct? Oh dang. Oh yeah, it's a bit behind. Oh, it's
Someone
pre-works.
is asking, but what is the proof that is this question the electron will follow Fermata principle of least time and follows same laws as reflection. Maybe the electrons don't follow normal equation of lengths of optics.
Oh,
But we don't have used any optics laws
yeah.
yet.
I guess the only thing is that we assume that it travels linearly. But like that's
Yes.
given in the diagram. So
Also, he might be confusing because we have fine focal length. So focal length is, look, we have used the similarity but not used the laws of optics.
yeah. Yeah. I mean, no one's really saying any of
Okay,
these.
for stream also the question is asked, so no one is answering. So we can I guess continue to the next question.
Okay. C2. In reality, the electron source is placed on the z-axis at a distance b is greater than f from the center of the ring. Uh, Consider that the electrons are no longer parallel to the z-axis before reaching the active region, but are emitted from a point source at a range of different angles, and gamma is less than 1 radian to the z-axis. Electrons are focused in a point situated at distance c from the ring. Find c. Express your answer in terms of the constant beta from question B1 and other known quantities.
Okay, so here we don't have parallel and emit from a source like this. We have this lens and the distance is B and C. This is B, this is C.
Yeah.
So we can do the same thing here also. Let this be R, then this, okay, from the center is there. So this big is R. So we have, now we have initial y velocity something y not, here all, do we have to assume kinetic energy initial E only, or we, it is not given?
Yeah, I think we assume it's E.
Okay. Then we have V, so we can break this into components. So this will be V times R by B, and this would be V only approximately.
Yeah.
So this is V R by B. So and Vy final equals to V R by C, and the time that is in this region is V D by V. So Fr by M equals to dB by dt, dV by dt, dVy by dt. So we have Fr, assuming it to be constant, times T, that is d times V, equals to change in Y. So V is constant, R is also constant. So 1 by C minus 1 by B.
Yeah.
So after plugging the value of F, we should get the answer C. And what was value of F?
Like 2 beta, 2 beta EQR.
E 2
QR.
beta QR. Yes. So we have 2 beta EQR T by VM, and this can be written as E, and R can be cancelled out, equals to 1 by C minus 1 by B. And this was our focal length, so 1 by C minus 1 by B equals to 1 by F, which is not the Lenz's law. Lenz's law, in Lenz's law this should be plus.
Yeah. I mean, which I guess shows that it's not exactly the same as optics.
Yes, or we might have done some mistake.
Oh yeah, that's true.
Okay, yes, yes, yes. This is plus and this is minus. So we have plus only. As this is V upwards and this is V downwards finally.
Okay.
So now this is Lenz's law.
So in part D now.
Sorry.
So should we move on to part D?
Yes. Or one more in part C is remaining.
No, it's basically what we just did. Is the equation
Oh,
for optical lens fulfilled?
yes.
Yeah. Okay.
So who is reading part D?
I can read the first part.
Okay.
The model I was considered above was idealized, and we assumed that the ring charged instantaneously. In reality, charging is not instantaneous, as the ring is a capacitor with a finite capacitance C. In this part, we'll analyze the properties of this capacitor. You might need the following integrals, and then uh, 1 over sine x, and then 1 over square root 1 plus x squared. And calculate the capacitance C of the ring. Consider that the ring has finite width 2a, but remember that a is much less than r. Bro, there's too much integration on this test.
So we have to find the capacitance of our doubly thick ring.
Yeah.
So, so do we have to assume plus Q here and minus Q here, or plus Q here and minus Q at infinity?
Let
I
me.
guess second should be the case because in first that is definitely wrong.
Okay.
But how will we find capacitance in this also?
I guess like there'll be like two contributions. Like we can find the potential, and then from there we can find the capacitance, I guess,
But potential of what?
of the ring.
But for capacitance, there should be plus Q and minus Q somewhere.
Oh.
Or we can find self energy of the ring and then equate with Q square by 2C.
Well, we could do that. Now, how do you calculate the self energy?
Yes, that is also my question. We don't know general formula for. If this was small, then we could have done by approximating like we previously did. But uh, this is large. Therefore, we can't do approximation and find at general distance r the electric field or potential.
Well, it says, wait. Okay, so I guess we can just.
Could we double integrate this as theta and phi? No, it would be there will be r1, r2, theta 1, theta 2. So, and, yes, you were saying something?
So, like, the capacitor arises because of some potential difference, right? So you
Yes.
can so you can try finding total potential that's the total potential difference in the ring, and then
Difference
use
between the lower ring and the upper ring, or the rings and the infinity?
just the lower ring and upper ring.
Okay. And how will we find that?
I guess we can just try integrating. So like you can consider like some element like this. Like so like this is like theta. Oh, wait. So then I guess you can assume that theta r. So this part is going to be bigger than the width of the ring. But actually, that one, I don't know how to really do it. Oh,
And also, this is not two rings. This is cylinder here in between.
yeah.
So what would be beneficial or disadvantage? Also?
Okay, we can. So like the total potential, there can be like the potential from this cutout, so like this part that we have, and then the other part will be from the rest of the ring that acts on it. So like for the first part,
So you are
since this
trying to
is
find energy or potential.
to find potential. So if it's like if like theta is small, then we don't have to worry about the curvature of the ring
But
or the cylinder.
for potential, potential of this part on this, I doesn't make any sense. It should be energy or potential at any point. Potential of two parts. If we have two charge Q1 and Q2, we have potential at point B due to Q1 and Q1, and we have energy due to Q1 Q2. So I guess energy would be better like that.
Okay. Yeah, and then we could use the capacitor formula once we find the self energy like this way. So we find both contributions of energy.
Yeah, we can find the self energy of the cylinder and then interaction energy of this plus the self energy of this, and self energy of this we can replicate this. Wait, but if we integrate, we double the quantity of interaction energy. We consider this in this, so we have to multiply a factor of half with interaction energy plus self energy of this E self of cylinder, and then integrate from 0 to 2 pi. So 1 of E interaction energy. Interaction energy would be potential due to Q charge, KQ by R, capital R here, and 2, and then dq plus self energy of the cylinder. That would be tricky. We have charge, let's say Q, and we have cylinder. What is the, okay, we can use Q square by 2C, and C of cylindrical capacitor. No, that won't work. How can we find the self energy of the cylinder?
Let me think. Oh.
Okay, we can just integrate this. We can equate Q square by 2C with integral field 2k lambda by R, that is here Q into L, Q by L, 2k lambda by R from energy density is E square 1 half epsilon naught E square into dv. dv is L times 2 pi r dr. So E square is 4 k square q square by L square r square. So 1 r gets eliminated and this 2 also gets eliminated. So we have 4. So 4 epsilon naught k square q square 1L gets eliminated by L pi and ln. Okay, that comes infinity. So this is useless. Do you have any ideas for this? My idea won't work as we have a limit of ln infinity by something r form, and that would tends infinity.
Yeah, that. No, I don't really know. I guess you can just skip then, since I don't know.
Yes. Or I guess we can continue it tomorrow
Yeah,
because
we can continue. We can continue for tomorrow.
we have done one and a half paper and we have total 3 papers. So it would be one.
Yeah, sure. Then I guess I can end the Livesolve here.
Yes. Or can you save this all the slides? So if we want to use it in future, then we can use it.
How do you save it?
Especially for the last problem, because E part might contain the use of previous parts.
Oh wait, I see. I see the save button. Okay, I saved it.
Yes. We have to go to every slide and do that save button.
Oh, for every button? Oh,
Yes.
okay. Okay, I'll just stop the stream now and then.
Yes, we can stop the stream and just save the.
Okay, thank you for watching the stream. And be sure to come by for tomorrow. Where we'll do the second part of T2 and also